but not with all of them. I just use the data in the variable b. No, sorry, I created another data, then created
Okay. So it worked fine, right?
yes, with the help of AI.
He said that it's the help of AI. Why did you need AI to do it? What happened?
Although when I try to when the code I wrote was not correct, so I used the AI to correct the codes, and it worked well.
Okay. Okay, let's look at but like mentioned, let's say we have, let's continue with what we have in the notes. Let's create some new variables. Let me initiate my kernel environment. Let's say study hours, right? Maimuna, you were not in class last week. You were the one that asked if class was going to hold, but you didn't come. So let's say we have this, and then we have the exam scores to be like this. Eighty-five, 91. All right, so it has loaded. I hope you can see the screen.
Yes.
All right.
Uh-huh.
So
Yeah, it's okay now.
we are trying to see how scatter, what scatter plus is, scatter plot, what it is, and how to use it, or what it is used for. I believe you guys went through the chart and you saw the use cases and why you would use a particular chart, like a bar chart. It's used to compare discrete categories. Use them when you want to answer questions like which class scored highest on test 3, or how does monthly revenue compare across regions. I'm very sure it's in the notes, right? So
Yes.
scatter plot, in the other hand, is very very important to for what's it called, correlation, right? To look at relationship. You use it to explore the relationship between numerical variables. What this means is that one of the typical way it's used is you would like to see how something affects another, right? For instance, like these are examples of exam scores and study hours. You are trying to see if a person's study hour, you know, this one we just created it now, but we will use real data and to see if this works the same way. You are trying to see
Mm.
if a person's study hour affects the person's exam score. What would you hope to see? That the exam score would increase as long as the person studies more, right? Like this your Python, if you practice more, would expect it to be very good. So it's used to look at correlation. How does one feature affect the other? Would this, would increase in this affect the increase of this, or if this increases, this one will decrease? Let's look at it. Let's plot it and see what we are trying to say. So the first thing is, of course, you import matplotlib dot py plot as plt, right? And then I could have done everything in this cell, but let's do it here so that it can be pure. So let's initialize our figure and axis, right? So fig plt dot subplots, right? And then you set the fig size equals to 8 by 5. What are we plotting? Scatter plot. 8 by 5 is fine. All right. So, and then what's the next thing? Once you've initialized or your fig size, figure, and axis, so you call on plt the scatter, and then you pass study hours, right? That means study hours will be in the x axis, right? Exam scores in the y axis, right? So let's leave it like that, and then plt dot show. I told you that anytime you want to plot something, start with the basic to see that you even got the plot correctly, not that you finish typing and you find a lot of errors, right? So this is a basic scatter plot with everything left to Matplotlib to decide. You just told it there is a scatter plot of study hours by exam scores, and it should show you the figure. What's the problem? All right, so this is large. Let's make it it's going to be, yeah. All right, so this is it. This is what a scatter plot is supposed to show, right? What this shows is that supposedly, with the increase of, let's keep going, Sha. You see, so this is the basic scatter plot. We've plotted it, and it is the basic. It doesn't have anything extra on it. It doesn't have the label for the x or the y axis or what's happening inside the scatter plot. So this can be done better by adding. So every plot has its own parameters or arguments you can add to the plot. For instance, scatter, just like any other plot, you can obviously add color. Like the color we used in our example is royal blue. You can add edge colors, which I doubt would actually work, but let's keep going. So you see that as you are adding, I hope you guys are still with me. I hope I'm not talking to myself.
We are with you.
All right. So you notice that as you are adding features,
Yes, sir, we are with you.
You notice that as you are adding features, what actually happens is that the plot keeps the code line keeps going further, and we don't actually want it like that. So one good thing about Python is that you can actually come down and continue your code, especially if it creates this indentation of 3 space, right? So the next thing is so that you not go out of page. Size 100, you would see the size is 100, then alpha is equal to 0.7. Would explain what all these things do, but let's execute it now and see what is happening here. All right. So as you can see, it is well defined now. You have edge color around it. The main color of the dots is royal blue, so the edge. So you can actually use, because it's going to if you don't use the same color, edge color is the color that is surrounding it. It's just like the outline. If you use something different, let's say black, it didn't change much, but It didn't change much. What if I use something like red? As you can see, doesn't make much sense. But you, when it comes to scatter plot, you would not want the edge color to be very defined, unlike in bar plots that you'd want it to stand out so that you'll be able to separate each bar from the other. But in scatter plots, you just want the edge color so that the dots would be well pronounced. So you put a color, maybe a darker color compared to the color of the dots themselves. So just like it was used here, I think is it navy that was used? So it's basically navy blue. As you can see, it's just a bit darker from the royal blue. So we can use different types of brown as well. We can use maybe purple will work fine also, or is it going to be too pronounced? All right, so as you can see, this is the interesting part of data analysis, and is actually why we ladies like it, because it has some designs you left. And the reason why Python is so good in visualization, every single part of the chart, unlike in Excel, every single thing is very, you can configure, you can twist and do with it anything anyhow you like you can decide very easily every single part of the plot. So what did we leave out? We left out the title, right? So sorry for those
Hello,
that
sir.
were absent.
Hello, sir.
Hello, I can hear you.
I'm trying to. My own is giving me error, so I don't know. Let me check your. I don't know
Okay,
what I'm doing wrong.
did you start
Yeah.
it gradually?
Yeah. I'm following what you are doing. So
You might
I
have
don't know.
missed a comma, because I think I missed a comma here the other time, so fix it. After each parameter you use a comma.
Mm, okay.
As I was coming down to the other next line in the plotting code, I forgot to put a comma after the edge colors, so I added a comma. So this s is equal to 100 is the size of each dot, each of the dots. So you can reduce it maybe to 50, right? So you see it's a bit smaller now, or you can add it based on your on the dots. If the dots are much, obviously the size will be smaller. Now this alpha can be removed completely so that you can see what will happen if you don't have it there. As you can see, it's well pronounced now, because alpha makes it a bit faded, a bit transparent. It's not well it's not a solid color, it's a bit transparent. So if you remove the alpha, it will bring it back to a solid color. Are you still there, Mr. Ispo? Is this still giving you?
Oh, I've seen where I made my mistake when I was creating my variable exam score.
Okay.
I've seen that.
All right, so the alpha can also be adjusted. If you want it to be more faded, maybe you can increase the alpha. Right, so, or you can decrease the alpha. Sorry, if you decrease the alpha, it will be more faded. If you increase it, it will lean towards more solid. And one thing you need to know about Python is this 0.4, right? In Python, when you are dealing with percentage is basically running. You see it coming across and coming like this 4 now is just like you saying 40%. You understand? 5 is 50%, 6 is 60%, up to 1. If it is 1, it means it's 100%. So you keep seeing something like 0.4, 0.04 will be like 4%. You understand? So I want you to keep in mind that you keep coming across this. Maybe when we keep going with Python, you will see it. That when we are dealing with percentage, if we want to say 70%, you would find that it's not 70% that is written. you find 0.7. This is 70%. If it is 7, it's going to be 0.07. So you please keep note of this, and then maybe as we go further we'll see other things. So we've added a title. So for Maimuna and the rest that missed the class, if you want to plot a graph in Python, depending on what kind of chart it is, bar chart, pie chart, right, histogram and the rest, the one of the best practices is this particular line of code. If you go through the notes, you see it, how you configure the figure and the axis, and then you decide what kind of chart it is, and you put the kind of chart here. You give it what you expect in the x and the y axis and other parameters like we've listed. This is some of the basic parameters scatter plots needs. So I think we will leave that one as that. So let's keep going. The label with
sorry sir,
yeah,
this alpha,
yeah,
while I was trying to follow your this and I missed what you explained about alpha.
is basically used for
This
transparency.
S equal to 50.
This is the size of the dot. It can be
Okay.
it can be more than that. Initially I used 100. So look at the size right now before I run it. You see it's this size. So when you run it, if it is in 100, it will be bigger.
Okay.
You see it, bro? So while alpha is transparency, it comes in handy when you are comparing multiple things. Like you can have multiple features here. Apart from this series of dots, you can have another series of dots. If you want to make one less visible, a bit faded or transparent, you use alpha. Alpha is saying, do not give me the solid color, just give me 70% of the solid color. This is what 0.7 means. So it will give you 30% transparency. If you make it 50, 0.5, this is 50% of the solid color. The transparency will be much. You see it will be more fader. You see, ba? So this is what alpha means. It's basically transparency. You know why you use it and how where it comes in handy. We just introduced it so that you know that it exists. It makes the dots a bit transparent, not as solid. If you remove it or if you make it 1.0, it will be solid. You understand? That means zero transparency. The color is presented 100% with zero transparency. That's what 1.0 means. All right, is that clear?
Yeah.
I hope you are with us, Mr. Yusuf.
Yeah, I'm trying to follow today. It's like I don't know what's happening.
Huh?
I'm struggling to follow.
Oh, you are typing?
Yeah, no, I want to, because at the end I want to have because the only way I'll be able to study at the end is have what we did in the class on my this
Yeah. So I'm actually using the note share.
Okay.
Yeah. So we have the X label and Y label. So this study hours versus exam score is the plt.title. I think I explained how you know if something is going to take its own line of code or if it is going to be part of what's it called? If it's going to be part of the plotting code. I said if what you are adding will not affect the graph itself. You know, this is like a graph book. This whole thing is like a graph book. The main graph is this, the main values are all these dots right here, right? So we said if what you are trying to add will not touch these dots, it is not going to be in the main scatter plot code. This scattered plt.scatter, because as you can see, even these edge colors, because it affects the dot, is inside the scatter plot. But adding title does not affect your dot. You can add title after you are done. So it takes a line of code. This is one of the wise way we use to tell, because people tend to be confused. label, is it inside this plt.scatter that you put x label and y label, or is it a standalone code on its own that plt can use? Is it a method? So it's not an plt.title is not an argument, meaning it's not inside this code. It's a method or a function standing on its own. plt.x label as well, plt.y label, which will give a label to the y-axis and the x-axis respectively. So let's run it again, right? So you see, y is the exam score, hours studied is the x-axis. So this is saying if you spend more hours studying, your exam score will be high, right? People that spend 8 hours a day got 90, even though it's not always like that. There are lazy students like myself. If we go to exam, we'll still answer, maybe it will still be the same. So the next thing is what we keep. Each one has this, a graph must have grid, even though Python allows you to do without grid so that it can be. So a graph must have grid, right? As you can see, this is the grid, and then you can do that thing that we used to do in mathematics. Which one is at the intersection, right? We have only this one that is 0, that is in the intersection. How they taught us how to plot slope. Share is the one that intersects that you use to plot slope. I haven't forgotten. So is this 90 and 40? So, but this is too vivid and it's actually interfering with the data. So grid also has alpha, right? It has alpha. What will alpha do to the grid? Grid has an argument alpha. What would it do, Mr. Yusuf?
No.
Menene alpha? Me ake da alpha?
Alpha kamar da
to make it solid or transparent.
Yawwa, it will fade it. So that, because this thing is too pronounced, this grid is too pronounced, and it's actually affecting the plot, the dots. So we can actually fade it and say we just want the solid color in 30%, right? That means this is 70% transparency. So when you run it now, you find that the grid is faded, like an old graph. You see it, ba? I hope it's clear. This one is better, ba?
Yeah.
So
Yeah.
So that's what alpha does. Alpha will fade it out. All right. So what is left in a typical plot? In a typical plot, let's assume all these plots. So now, as a data analyst, we've reached the point of plotting graphs that you will now explain. For instance, even though we just made up this figure, this data, this is supposed to be data that you don't know what it is, and you don't actually know, because the data is much, you don't actually know if study hours affect exam score. It was only after you plotted this scatter plot that you noticed that with an increase in exam score, study hours also, sorry, to an increase in study hours, exam scores also increased. So probably this is a good analysis that you can now add a note to. So it now depends. I like mentioning this at each junction when we reach a very important junction. It now depends who you are presenting this result to. If it is someone technical, probably your notebook will suffice. But if you are trying to present this as maybe a result, you want to present a report that will carry the visualization and explanation of what is happening, you have a report, you would probably need this graph, right? So I think the last thing left in a typical scatter plot will be the saving code, right? So if you want to save it, we mentioned this, that is going to be plt.save fig, and then let's call it comparison.png, right? So once it's saved, it's going to be saved in your project folder. So once you execute this, you will now have an image of this particular figure in your project folder. So let's look at the project folder. We should see comparison there. Yes, so this is comparison is there, comparison.png, right? So any question? Any question?
I don't know whether it's because of the heat today. I'm just struggling to, but it will be okay, inshallah. Well, after the class, I'll go through, follow the note, and
All right.
sir, please, I believe this class is also recorded.
Yeah, I'm recording it.
Alhamdulillah, that's good.
So now let's look at histogram. Please, it might be it's in the notes. If you don't understand the use cases for each chart, maybe you can search the net. But it's in the notes because it's very, very confusing. Sometimes it's not as if they will tell you which chart. In what am I saying? Most times nobody will tell you which chart to create. Nobody will tell you if it is bar chart or you need to use the data and look for and answer the question of ask yourself what answers you are looking for. Those answers you are looking for will determine which chart you are going to use. So it's very, very important you know the use case for each chart. Like I said, for scatter is for creating for visualizing relationships, right? What about histogram? Histogram, what is it used for? So it's used to show distribution of, and we deal with variable in data analysis and data science. It is used to show distribution of a single numerical variable. For instance, how often values will fall into a particular range, right? So it's essential before any statistical analysis to check if data is normally distributed, skewed, or has outliers, right? So if you are talking about the age of, let's say, pupils in your class, you can count how many fall in the age range of, maybe if you have how many fall in the range of let's say 10 to 12, 13 to kaza. You understand all these things like this. So if you recall histogram in mathematics, you did it in WAEC. You must have done it in WAEC, so you will know what I'm talking about. Let's take for instance the way it is presented in WAEC. Most times in WAEC, histogram comes as they will give you a series of scores, right? 50 scores that you are supposed to tally. Take the tally and take the frequency. Am I communicator? You people have forgotten WAEC. Maybe some of you are even mathematicians or statisticians. Do you recall this histogram that they will give you many scores, many figures that you are supposed to tally?
Yes, sir.
And put into a range?
Yes,
sir. So this is what I'm saying. So this is how histogram is used. Let's get some scores and put them in a range. So you count the frequency, and then later you take the mean, take the y. You remember all these things, yeah? So that's what we are trying to see. So
median mode.
So you might have this in your data frame rather. So you would want to make sense of it using your histogram. 80. You would like to see how it's distributed. Remember that time you count it will not be up to 50, and n is supposed to be 50. You have to go back and check again. It's 90, 91, 93, 95, 96, 99. All right, so you might be given this in your exams question, question, and you'll be told to give the range. Which ones fall between 40 to 50, 51 to 60, 61 to 70, and all those things. So this is a typical histogram, but we want to use it to plot the histogram. We don't have to count. We don't have to do the range ourselves this time. We already have a figure, I beg. Let's not create another figure. But since it's histogram, let's see how this one is. Well, it will work. It will work as well. It will work. All right, so let's just go with plt.hist, right? And then create scores, right? So as you can see, you already see a difference. Histogram doesn't take x and y arguments, because it's supposed to show a distribution of a collection of data, not showing relationship. It's not used to show relationship. It shows distribution, right? So it's normally a single variable. You are not providing x and y. You only have a single variable. So the default of it is just plt.hist, give it the variable, and then plt.show, right? So let's run it and see. This is the histogram. So obviously one of the main difference between histogram and bar chart is that histogram are merged together, right? Then the eye is not as if they are separated, they are showing distribution. So as you can see, we have those between the 50 range, between 50 and 60, between 60 and 70, between 70 and 80, and so on and so forth. But you need to know on something else. As you can see, you can actually count the bins you have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one of this and that, these bars in histogram are called bins. They are bins, BINS. So you can actually control how many bins you have, how many bins can be used, because let's say, for instance, now we see that this one, it doesn't say much about the data. So there's an argument you can add called bins, which is called to, let's say, 8, for instance, to see if it is going to be a much more pronounced. I don't like the way it is, so let's add the bins. Let's say, instead of reducing it, let's add. I think I prefer this one. So what the bins show is how many groups you are dividing the data into. How many groups do you want to divide the data into? Is it that data 40 to 60 is one group, or is it 40 to 10? What's it called? Is it 40 to 50 that is one group? Or is it 40 to, you understand? So depending on what range you have, what range you decide to use, will determine the bin you are presented with, right? So as you see, as you increase the range, as you increase it bins, as you increase the range, the bins becomes smaller. It's not as wide as before. If I reduce it now, it means I would have to expand the range. If the bins is 8, that means I have to divide the whole data into 8 groups. Let's go back to our data. Let's say you have 45 to 90. Typically in WAEC, how many ranges? What are the ranges? What would the range be? If people are not answering, if people did not do WAEC, is it going to be 40 to 49? 50 to 59? See, that's what I'm trying to ask. Or are you going to make it 40 to 60, or 40 to 59, 60 to 79? You understand what I'm saying?
40 to 45.
40 to, you want to increase the range?
Okay.
The range will be much now.
50.
Will be more. Okay.
Because I want you to
Okay.
that's why I want
It
you to
will be
understand bin. If you say 40 to
40.
45, that means 40 to 45 is one bin. 46 to 50 is two bin. 50 to 55 is three bin, is the third bin. You understand? Continuously. So you might have like 20 bins here. Go back. So if for instance it is 40 to 50, that means you have from 40 to 51, 51 to 62, 73, 84, 95, 100, 6. Let's say it's 6. So this will determine the number of bins you have. You see it's back? You see it's bigger now. That means you have 6 ranges. Do you know that many people go through data analysis without understanding bins and what it's used for, because they did not do it in mass? Bins means how are you ranging your data, the values you have. So this one I just did now is trying to say the value starts from 40 to what?
50.
All right. So as you can see, it's like that. So 1, 2, 3, 4, 5, 6. You have 6 ranges. So that's how range works. Bins work in a histogram. Any question before we add more arguments? Any question or confusion?
My own question is,
yeah,
under this score, I saw that you give space before
I what?
wrote the remaining number. Under this course, I saw that you gave space. This space.
This was?
Yes.
I didn't give it myself.
Is it that we have to give space? Okay.
If you are typing in a code, right? You are typing a code and you reach a point, we don't want it to keep going now, just like I explained. So if you reach a point, after I put comma here, I just clicked on enter. On its own, it will give you an indentation. It will give you the space, because it knows that it's not as if you want to start from the beginning. It's a continuation of the previous line of code.
Okay, I understand now.
All right, so as you can see, we did the same thing here. I just clicked on enter and it came down. I want to add, so there are a lot of colors you can go through. You can check you can browse Matplotlib colors, or what's it called? A chart color in Matplotlib. You can just browse it and see what you come up with, what other colors you can use. All right, so we add the edge color. Why would it be white? I don't want it to be white. Okay, let's leave it white. Let's see what happens. So it's going to create, like, it will now make it look like it's bar chart, right? This white color. So you can now see the bins very clearly. As you can see, these are the bins, right? So this is coming from 45 to 55, 55 to 65, 66 to, you understand what's happening. So if you increase the bins, let's make the bins 8 rather. Can you see it now? Hello.
Yes, I can see it, sir.
All right. So it's more pronounced now compared to if you don't add an edge color. So you see what this edge color did was, it will make it stand, it will make you see, one of the advantages of the edge color for each bar chart is different. Like for this one now, you can see the bins clearly and you can see where the range stops. All right, so what do we have left? What didn't we add? Not in the main code. Anything to add?
Title.
All right, so we've not added the plt.title, right? So it can be what, distribution. Who is doing hammer? You want to sleep?
No, it's in a tiredness.
plt.x label, right? Scores, score range, right? Based on your bin, plt.y label. So plt.y label will now be number of students in that range, number of students, cool, in that particular range. So let's run it so that you see what we are typing. So these are the number of students in each score range. So the number of students that score between 45 to 55 is just one. 55 to below 60. Is it below 60? Let's even look at the data. Okay, 55, 58 below 60 is 3. As you can see, 1, 2, 3. I think that's what they are trying to say. So and so on and so forth. The highest range is between 70 and 80. You see, 6 students are between 70 and 80. Look at it. Right. These are the 6 students. 70 is not included because the previous bin includes 70. So apart from 70, 71, 72, 73, 74. Okay, 71 too is not included. It's like this. Is this 6? They are the highest range. So this is how you plot. The simplest way to plot histogram. Any question? So a tall bar in the middle like we have here and short bar at the end, this shows that this is a roughly normal distribution, right? Even though it's not that normal, hadn't been this tallest bar is around here, it will show that the data is skewed. It's still a bit skewed. Think that it did not fall off here again, but it's still a bit okay. Any question?
Understood. So, hello, sir.
Yes, sir.
Let me ask you a question here.
Yeah.
Now, you stated earlier that while creating the fig, say the histogram does not, carry the argument of x and y. So now we are adding titles to x and y, and it is taking it. So I want to know why is that.
You are not the one defining x or y axis. All you provided to it is x. The first, okay, let me put it this way. It doesn't need y because it will provide y itself. Think that it is distribution. All the things, what a histogram is doing is helping you to count how many values fall in a particular range. So all you need to do is provide it the values, and it will give the values ranges here. It will now be the one that counts. You are not the one that counted it. What it's doing is what you have here, 1, 2, 3, that all these things fell to show you each one, is it went back. If you remember tally in secondary school, it is tallying, it is the one that tallied these values and actually showed you how many fall in each range. So you are only providing it the values, and maybe let's not say it doesn't put, let's say you only give it x axis. Let's just use that word like that. You give it the x, the variable it will use. It's not even x axis. You just provided the variable it will use to that it will count, and you understand what I'm saying basically. So it's counting the values, it will now give it range. This y, you are not in control of it. It will be the one that will count each value and give it a range and divide them into ranges, into bins or into range, right? So that's exactly what's happening.
Understood.
So let's just say you provide x-axis, mutapa aka. You will want to provide x and it will deal with y. So no more question, Ko?
Question.
Now?
I have a question.
Okay. I did hear you.
That line with.
Okay, yeah.
I don't understand.
Yeah. Where is our line width? Let's do like this so that you know how it is like this, but let's do like this so that maybe you can see. Let's put something lesser so that maybe you can see the difference. Is it different from the way it was before? Do you even need the line width in Histogram? It's talking about the width, it's online. I don't think it's that important. So let's assume you removed it. Forget about the line width for Histogram. It's the width of the line of each bin. But I think in Histogram it's not that as pronounced as it would be in what's it called? Line plots, because regardless of whether these lines are thick or not, it doesn't make much difference in Histogram. So thickness is basically means thickness. If you check line plots, you see it. Let's see, do we have line plots here so that we can add a width to it? Let's make this line width and make this 0.6. I need to run okay, yeah. So at 0.6, let's add the thickness so that we can see. If you see the line, it's very, very fine. If you add the thickness, it should be thicker than it was before. As you can see, you can make it lighter. If you want it to be just like a pencil line, if you make it 0.3 for instance, it's going to be very, very thin. Can you see the thinness now? Or is it not, or you don't understand what I'm doing? Who asked for line width?
I think I tried.
But Mr. Yusuf, you know what it does now?
Yes.
Right. Mr. Yusuf, you know what it does now?
Yes.
Sunny, I don't understand.
I don't understand. I don't understand.
Yes.
Okay. As you can see, mute your mic so that I can explain. As you can see, this line, this is a line plot. This is not, is another type of plot. You have bar chart. Maybe if you go through the note, you see it. You have bar chart, you have bar plot, you have a histogram and the rest. So this is also a line plot, a different kind of chart. You use a line to show the data, right? To visualize the data. But the width is going to show how thick the line is. Is it very vivid? Like, look at this barrier background line now. It's very, very thick. But this our line is very, very thin because I set the line width. Forget about all the other codes. You will see maybe when you are reading, you check the code again. It's very, very simple if you've understood the one we did before. I set the line width to 0.3. If I want it to be as thick as maybe this one now, I can set it as 0.9, which is 90% line width. So when you run it again, you see that it's thicker than it was before. You see it, ba? So this is what the line width does. It increases the thickness of your chart, the lines in your chart. Is it clear?
Yes, sir. Thank you.
Yeah. So the what we have next in our agenda is pie. Where is Malam Silly? That kept asking us about these pie charts. So pie chart is very similar to bar chart. In fact, sometimes they are interchangeable, but because you find that in Python they hardly use pie charts because it's not that used that hard, because sometimes it's hard to read when you have more than 5 or 6 slices. As a data analyst, you know that most times you definitely have a lot of categories you want to compare or show. Like in bar chart, you can actually visualize multiple categories, but in pie chart, it gets more difficult to read as the categories get much. You know, the slices will be much, right? So let's assume you want to show population of each state, and you decided to do it in pie chart. Think about how the slices would look like in the cycle. You know, it's going to be it's going to be much because you have 36 states, but in bar chart it's going to be very easy to display. So they are interchangeable. You can use them, you can use anyone. That's why you find that in Python you keep noticing that it hardly comes up. People don't like using it except for strict cases, and even in those cases they use donut charts, not pie chart. So but for the sake of our class, we'll look at it and see how it's done. All right, so it needs a category. Like let's say you want to see scores of males and females, right? So but let's use the example we have. Assuming you are looking at how many people listed any of these as their skills. You gathered some tech or data analysts, and then they listed their skills, and you would like to see how many did mention each skill. Like how many mentioned Python as their skill, how many mentioned SQL, how many mentioned Excel, how many you mentioned Power BI, and how many mentioned other skills, right? So this is the categories and the counts. If this was a bar chart, it's very simple. You just plot categories in fact, can we plot a bar chart? So it's plt.bar, right? So it's going to be categories and then counts plt.show, right? So as you can see, very very simple something. Python has the most mentions, right? Then SQL, then Excel, then Power BI, and some said other skills. I hope I'm communicating. You see how simple it is to plot a bar chart now without anything extra. Just give the categories, which should be in the x-axis, and the counts. Or should I wait so that you can do it, Mr. Yusuf?
Continue. Since I'm going to have that, I'll stop doing it for long so I can pay attention more attention.
All right, so
pay adequate attention to the class.
So this is a simple bar chart. So assuming you have more categories here, let's say Java, CSS, and a lot more, bar chart can simply plot it. In fact, but even in bar charts, it becomes a bit more complicated if you keep plotting. If the categories keep getting let's say you keep getting more categories, you know it will reach a point where it's going to be difficult for you it's not going to look nice, right? Because you are going horizontally. Let's say here will now be HTML, Java, C++, C#, a JavaScript, TypeScript, Flutter, you keep going, you see it's not going to make sense. That is exactly why horizontal bar chart was introduced, because with horizontal, the figures, the categories, instead of going like this, they will just be going down, and then the scores, definitely the scores will not be unlimited. The categories will be going down. We'll see. Let's plot a bar, a horizontal bar, so that you can see what I'm saying. So this time, categories will not be in the x axis. It's counts that will be in the x, and then categories in the y. plt.show. Oh, sorry, it's going to be the same thing, don't mind me. As you can see, so that means even if you have other categories, you can keep listing them, and all it will do is just go down instead of going sideways and then occupy space, or it will not look nice to read. I hope I am communicating.
Yes, sir.
All right, so we'll see an example later on, Sha. So let's define a new figure for our pie chart. Let's define a new figure. Why would we need to define a new figure for pie plot, for pie charts? Because we've been using rectangles since, right? We've been using rectangles, and it so happened that pie chart is a circle. You know a circle?
Okay.
Now?
No, I'm with you. Sorry,
Okay. You know a circle is we need a square, because all sides are equal. Definitely, it's a circle, not a sphere, not an oval shape, right? So we are using a circle, and then in pie charts you only provide x-axis, right? You only provide the counts. So that you understand, let's say you only provide the value you want to count, right? And then instead of having x-axis, you have labels, right? Which the labels are the categories which we use to label those axes after it's been counted, after it's been proportioned. It's about giving slices and the rest. So let's just plot it so that you understand what I'm saying. So let's say categories is the labels is categories, and then let's leave it like that so that we can see the basic pie charts. Look at it. See Amba? And as you can see, any question?
So I want to see the code you passed to get this space.
It's the basic code for a pie chart. Give it the values, and then the categories will be saved as labels.
Okay, that's it.
All right, so you can actually add something called explode so that it will look nicer. What explode would do is you can decide the way I normally do it is that I play around with the values and see what it can produce. Is it going to be, as you can see, explode will give you gap between each of the slices so that it can stand out and you can understand it better. So you see, like I was telling you about pie chart, about Python, it's not about clicking that. You just, everything can be controlled. As you can see, once you add explode, it will divide the slices, each slice standing on its own. Is it clear?
Yes, sir.
So
Sir.
we can play with, let's play around with this explode and see what will happen. Okay, this is going to give us an error. Let's say so you can reduce it, you can add it, as you can see, it can be added, it can be reduced. Don't worry, this is all in the notes, in that last note I sent on visualization with Matplotlib. You can go through it and you can practice. Now for colors, mind you, when you are adding colors, what's the difference between these colors and then the argument color here? In histogram and the likes, the color is just one, not plural. But here you are saying colors because it's expecting multiple colors. Since it's already a pie chart, it knows that it should be expecting multiple colors. So we have, and each category's color must be mentioned. If not, it will return an error. You have 1, 2, 3, 4, 5. Let's say you make it red. Why am I using capital letter? Red, blue, purple, brown. It's 5, cool. Black. You see, you can change the color. You can use the colors you like. So if you like design, there are a lot of things you can do in Python. And this is just Matplotlib, not even Seaborn. Seaborn is much, much better. Any question?
No question.
All right, so one last thing, so that before we call it a day, since we started, I don't think we started early. One last thing is the question Yusuf was asking in class. Suleiman was, I think, is this Suleiman or Yusuf? Someone was asking, why do we define it with big subplots, those subplots, right? It's because at default, Python knows, I know I explained in class, that you might want to have multiple charts side by side, right? You can display several charts in a grid layout using just plt.subplots and provide how many charts are in one row, how many rows you have, and how many columns. So it is perfect for comparing chart types on the same data or showing different variables on one page. Let's see what we can do. Let's say, are you sure we can do this today, or is it going to take, or should we call it today, or should we still do it? Let's say you have test scores. Right, and then it's 1, 2, 3, 4, 5. We want to see the use of that first line of code we keep using. Class A 10 24 18 32 29. Class B. Was Aisha able to log in? I've even forgotten. I did not even check.
She's on, right? So I was gonna ask. I don't unless you have an Aisha, but one Aisha asked about length.
Okay.
At that time.
So we have plt.subplot. Let's make it axis since we know that we are expecting multiple subplots, right? And then you now say 1 2. You can let me not confuse you guys so that we can explain this. So let's run this so that you can see what is happening. Plt.show without creating any plot. Let's run this. All right. So you are saying in the same graph paper, the same paper you opened, you created, you want 2 plots side by side. This is what 1 2 is saying. 1 is saying it should just be 1 row, meaning they should be side by side. It's 2 plots, 1 column, 1 row, 2 columns. So it's 1 row like this, 2 columns, 1 plot, 2 plots. So if you say, let's say 2 rows, 2 columns, or 2 rows, 1 column, they are going to stand on each other. You understand? So this thing here means rows, column. Am I confusing you? We have not plotted anything. We are just looking at our graph book now. Is it clear or is confusing?
So I think I don't know. Let me not skip for order, but like for me, I'm kind of expressing diminishing return now.
Oh, we should leave it till we meet maybe on Thursday,
yes.
Ba?
Next class.
Do we all hold the same
view?
Yes, we should leave it.
Yes, sir.
You don't want to see this. Do I care? Let's stop here. We'll explain. This is very I like this particular part. Basically it's what you use to explain why you have subplots here, but we'll explain it. We'll look at it when we meet in class on Thursday, inshallah.
Thank you, sir.
Or if we are free tomorrow, we can see if we can have the class so that we can make up for last week's class we missed.
It depends on the time because tomorrow the train PT always gone. Yeah.
Okay.
Dario.
Okay. We'll leave it till Thursday, inshallah.
Okay.
So let's stop this recording. Our class is too short. We only spent 1 hour in this class. 1 hour 8 minutes. 1 hour 8 minutes.
Okay. Why is not reading 1 hour 36 minutes?
We learned a lot.
The class today is a lot came down. So let's see how we digest it and.
All right. So let me save this video sharply and put it on YouTube before I forget again.
Okay, thank you.
I'll go and digest it. All right, bye. Say the side.
Thank you, sir. Okay, good night, sir.
All right, bye. Say the side.
Thank you, sir.
Good night.
Thank you, sir.